Megan, are you okay? No? Yeah? No?
All right, so 7 and 8, we did ones like this before, I think as a homework assignment. So you should kind of know what's going on with these a little bit. When it says to take the graph and do a dilation of 1/2, what does that mean that you need to do?
Make it half of it?
What do you do to all of the points on the graph?
Put them down?
Right, you divide them all by 2. And so the very first point we could look at if we wanted to, this one right over here, 0, 2. If I divide that by 2, what do I get? 0, 1. So I'd have a point right there. If I take this one over here, 4, 1, and divide that by 2, then I get 2, 1/2. If I take this one here, 3, 3, and divide it by 2, I get 1/2, 1 1/2. And finally, if I take the one in the upper right-hand corner, 4, 6, and divide it by 2, I get 2, 3. Okay? So that gives me this new shape that is a dilation of the bigger shape by a scale factor of 1/2. So if you look at these, you should notice that they're the same shape. They're just different sizes, okay? So what is the ratio of the perimeter of the dilated figure to the perimeter of the original quadrilateral? It's double. Well, the original one was bigger, so yeah, so it's 1/2. Right. So depending on which way you go, I guess, either doubled or 1/2. So remember that the perimeter, this is an important concept for you to understand, that's going to be on your quiz and test and all those fun things. The perimeter is the same. So if you double this, all the coordinates, you double the perimeter. If you cut all of them in half, you cut the perimeter in half. All right? That's always going to be the same. That is not the case, as we talked about before, with the area, which is what they want you to take a look at on the next one. So for this one, we're going to start with the shape, and now we're going to make the shape bigger. So this one is at 2, 1, 4, 1, and 1, 2. Okay? And then it says a scale factor of 2. So what do I do with all the coordinates this time? Times them by 2. So instead of being at 2, 1, I'm going to be at 4, 2. And instead of being at 4, 1, I'm going to be at 8, 2. Double them both. And for this one here, instead of being at 1, 2, I'm going to be at 2, 4. So that is my new shape. Okay? Now it says, what is the ratio of the area of the dilated triangle to the original triangle? What's the area of the small one? It's a triangle, yes? So the formula for the area of a triangle is 1/2 base times height. What's the length of this base? 1, 2, 3, 4. What's the height right here? 1. 4 times 1 is 4, and half of 4 is 2. So the area of the small one is 2. What's the area of the big one? Length of the base is 1, 2, 3, 4, 5, 6, 7, 8. What's the height? 2. So 8 times 2 is 16, and half of 16 is 8. So how much bigger is the area of the big one than of the original one? 4, like Brandon said. Why? Right, because area is squared, and so if you double everything, then the area that you end up with is actually 4 times as big as what you started with. Okay?
Yeah.
So those are both very important things for you to remember. Perimeter is the same, area is always squared. Okay? Okay, what about the back side? Any questions on that?
2.
Number 9? 7, 8, 9? And 5? Okay? Alright, so let's start with number 5 then.
Mr. Aldrich, we have a few minutes at the end of class, so we just gotta actually just settle to figure out.
Well, I'm trying to teach you how to do it right now, so please let's not wait till the end of class. Let's get it going right now. Okay? So when I'm up here doing something, pay attention, and if you don't understand what I did, ask me. Okay? This is part of the teaching right now. Okay, so number 5 says, explain why CAT, triangle CAT, is similar to triangle BAG. Okay? What? Angle, angle. How do you know?
It's G if you're both right angles and A is the
Okay.
same angle.
Okay, so Brandon's got that easy. Remember, to prove that 2 triangles are similar, all we need to know is that 2 of the angles are the same. And he says since angle G and angle T are both labeled as right angles, that's one angle. And then since angle A right here is an angle in both of the triangles, it's obviously congruent to itself. So there's my second angle. So those 2 triangles are similar by angle, angle. Okay, does that help, Jake?
Yes.
You need 6 also, or just that part? Okay, so by angle, angle. All right, so let's take a look at these last 3. Number 7 has this little kind of bow tie set up. And we're told that these 2 lines are parallel. And we're trying to figure out what 2 triangles are similar. And so the way that you do that is you just have to match up angles that are the same. So if I randomly decide to start with angle A, what angle in the smaller triangle is angle A congruent to? E. Why?
Opposite here.
Good, because they said that these 2 lines are parallel and these 2 angles are alternate interior angles, so they will be the same. So that means when I write my similarity statement, A, Brandon, this is for you, Brandon, A and E both have to be in the same spot. So I'm going to put them first. You don't have to do that. You could put them second or you could put them last, but they have to match up, okay? Then I know that angle B goes with what angle in the smaller triangle? D, for the same reason. So if I write B next here, then I have to write D next there. Those also have to match up. What? And then the last angle that I know is the same is angle C. And I know that's congruent to itself because of vertical angles. So triangle ABC is similar to triangle EDC. And how did we figure that out?
By using our method of smartness. Angle, angle, angle.
By using our method of smartness, also known as angle, angle, which is the same as the last one. So A and E have to match up, B and D have to match up, and C have to match up because they're the same. Okay? Yeah. You just don't like me very much, do we? No, that's fine. We'll get this time. It's okay. Whatever. I thought, you know, that we knew each other all year. Okay, number 8. Same kind of deal, but now our triangles are inside a circle. And you might think that this is going to be the same as the last one. But if you did, you would be wrong. Because what is not true about these two segments here that was true in the other one? Right, these other ones that were parallel in the other diagram, and here they are not. Okay? So this angle right here, angle P, does not go with angle T. These are not alternate interior angles. Okay? What angle does angle P go with in this case?
S.
It goes with S. Why?
Yes.
Because it's the same mark.
Right, because this angle right here, QPT, marks off this arc. And this angle right here, QST, intercepts the same arc. And so if they intercept the same arc, they must be congruent to each other. So P, in this case, matches up with S, which means now the rest should be gravy. That means that Q goes with T. And that means this one in the middle, R, goes with itself. And we knew that once again by angle.
Smartness
Did
of
you
us.
get that taken care of, or do you have to leave my class? You have to leave
Tomorrow morning.
tomorrow morning.
Classic.
Classic Travers, right there. That
Actually,
kid.
it's awesome.
I am not going to call him Ossican.
Figure's good.
That's not going to happen.
Good.
No, I didn't.
Good.
All right, last one. We've got two triangles in there. They're overlapping each other. And we need to figure out which ones or how to write the similarity. So same thing as before. Give me two angles that match up. M and what? M and N. Okay? Why do we know that angle M matches up with angle N? Corresponding angles, because of those parallel lines. Good. Give me another one. L and O, those match up with each other. Why? Same reason, corresponding angles. Okay, and then finally the last one. K is obviously congruent to itself. And so those two triangles are also similar by angle, angle. And that's the most common way that you're going to find to prove two triangles are similar. Okay? Okay, so we good?
See.
Yes.